Okay, this is part 2 of our tutorial on test 8.5 DEF, and I'm on number 11. New substances formed during a chemical reaction are indicated. Okay, so guys, it goes straight back to the lesson. And in the lesson, if you remember, we had this part or this explanation on page 151. You have reactants on the left, products on the right. Okay? On the left side of the equation are called, on the right side of the equation are called products. That's true. On the right side of the equation are called new substances formed. Okay, so we want to look for products. New substances that are formed, those are products. They are on the right side of the equation, and they are called products. Okay, and if I didn't know that for sure, I would look at my example from page 151. Number 12, in a chemical equation, it is true that, the reactants and the products can have different numbers of atoms for each element. There can be different elements on the reactant and product side. An element or compound must be accompanied by a phase change. Coefficients, okay, so which one is the best answer? The reactants and the products can have different numbers of atoms for each element. No, I have to have the same number and the same kind of atoms on both sides of the equation, otherwise it's not balanced. Okay, G, there can be different elements on the reactant and product side. No, you can just rearrange the elements, but the same elements have to be on both sides. An element or compound must be accompanied by a phase change, meaning like melting, freezing, boiling, something like that. That is not the case. Coefficients indicate the number of molecules of each reactant used and the number of molecules of each product made. That is a true statement. The coefficients, remember, are the large numbers in front of the chemical formulas. Number 13. Which of these equations shows rust forming when oxygen reacts with iron? Okay, so first of all, on the reactant side, we have our reactants, oxygen and iron. On the product side, we have what we formed, Fe2O3. So we should have these two combining to yield this. Okay? So I have oxygen and iron yielding iron oxide. I have oxygen and iron yielding iron oxide. So those two are my choices because this one is trying to tell you that iron oxide is breaking down to yield these two. So that's backwards. And the same thing with D. All right, now I need to look and see which of these is balanced. I have 3 times 2, 6 oxygen here. 2 times 3, 6 oxygen here. 4 irons and 2 times 2, 4 irons. Probably is going to be B, but let's double check. Oh, I didn't even realize. Sorry, the yield sign is right there. That's not even it. Okay, I thought that was a plus and the yield is over here. So B is our only possible choice. Number 14, which of the following chemical equations is balanced? Follows the law of conservation of mass. 3 sodiums, 3 sodiums. 2 chlorines, but 1 times 3, 3 chlorines over here, so it's not F. 3 silvers, 3 silvers. 3 times 1, 3 bromines, 3 bromines. 1 gallium, 1 gallium. 1 phosphorus, 1 phosphorus, 4 oxygen, 4 oxygen. Okay, so I don't see any problem with that one so far. Let's look at the other ones. 1 carbon, but 6 carbons over here. I don't even have to go any further. I know it's not balanced. 2 times 2 is 4 hydrogens. 2 times 2, 4 hydrogens, but then there's a 5th hydrogen. So it's not going to be J either. All right, so the only one that's balanced is G. 15, the chemical equation above demonstrates that matter cannot be created or destroyed by a chemical reaction. Well, I don't know. Is it balanced? 2 zinc, 2 zinc, 2 times 1 is 2 hydrogens, 2 hydrogens, 2 times 1, 2 chlorines, then there's 2 chlorines. Okay, so it is balanced. It does show that matter cannot be created or destroyed by a chemical reaction. You don't have reactants being the same as products. Remember, they rearrange themselves and give themselves totally different properties. Number of molecules in the reactant is equal to the number of molecules in the product. The number of molecules doesn't have to be the same. The total number of atoms and the total different types of elements that you have to be the same. So C is not correct. Atoms on the reactant side are changed into different atoms on the product side. That would be like saying that zinc magically becomes copper or something like that. That can't happen. Okay? You have the same elements on both sides in the same amounts. It's just they can be combined with other elements to form different chemical compounds. All right, number 16, which of the following models best demonstrates a balanced chemical equation? So you have to have the same number and same type of atoms on both sides. I have 1 and 1, 2 and 2. So F looks good. I have one of these, but 2 of these and only 1 of these. Okay, G, I have 1, but I have 2 over here, so that's not balanced. 2 of these here, but only 1 on the product side. That's not balanced. It's going to be F. Okay, let's go to 17. A scientist performed an investigation in which different solid substances were added to 4 different beakers containing the same amount of water, and after stirring the combined substances for 2 minutes, the scientist recorded the observations in the table below. In investigation 1, it says when mixed, the substances separated with one on top and one on top of the other layers. Okay, separating has more to do with like density and whether things will dissolve in one another. But those 2 things that I just mentioned are both physical changes or physical properties. Number 2, when mixed, the clear substances turned yellow. Clear to yellow is a color change. When mixed, the temperature of the substances increased, temperature change, and bubbles, formation of a gas. When mixed, the temperature of the substances decreased, temperature change again, and a solid substance formed, probably a precipitate. Okay? So the results of which of the above investigations indicates that these substances least likely reacted chemically? Okay? On investigation 2, there is evidence of a chemical reaction, a color change. On investigation number 3, there are 2 indications of a chemical reaction, a temperature change and the formation of a gas. On number 4, there are 2 things that indicate a chemical reaction, a temperature change and the formation of a precipitate. The only investigation where you don't see any evidence of a chemical reaction is investigation 1. So that's going to be answer choice A. Okay, so before I go on to number 18, just to prove that you're listening, you're not going to see me write it, but draw a little smiley face next to number 18. Okay, and obviously you won't see me do it because I'm asking you to do it because you're listening. Which of the following statements above is true? All right. Subscripts are used to identify substances. Coefficients are used to identify substances. Chemical formulas are used to identify substances. That would be true. The elements and the number of atoms of each element present in a chemical formula are used to identify substances. That's true. These 2 by themselves are not accurate enough. So let's go with number 3 and number 4. That's G. All right, last one, number 19. During an investigation, a student combined 2 substances as shown below. Refer to the information and the image shown above. The student observed a decrease in temperature when the substances were combined. A milky substance formed and sank to the bottom of the flask. What was the most likely reason for these results? Okay. Reason for the decrease in temperature. Reason for the milky substance. Okay. A temperature change and the formation of a precipitate are both pieces of evidence that a chemical reaction has taken place. So that's going to be C, that the substances combined chemically or chemically reacted. Okay? Make sure that you go through, you have all the right answers. Make sure that if you haven't gotten your test signed yet, that you do that. Get a parent to sign it. And then you can talk to me about when the retest is. All right, thanks, guys.